This is an example of a conversion within the metric system. Convert 2.94 kilograms to grams. We're not given a conversion factor here because we should know what kilo means. So we look at this problem and we see here's our number, 2.94. Yeah. Come on. You got to talk nicely to the iPad mini because it's just a little guy and he doesn't like it when you get cross with him. There we go. There's our number. We're starting with kilograms, and it says convert 2 grams. And then we look at these units that we have here. They're both gram. One of them has a prefix, kilo. One of them does not. There's one prefix. It's a one-step problem. I think we've got another one coming up where we've got 2 prefixes. Then we have 2 steps. So again, we stick our units in. We start with the number that we're given, 2.94 kilograms. We multiply by a conversion factor. We want grams on top and kilograms on the bottom. So the units work out. Kilograms, cancel the kilograms. The previous problem we had the relationship just handed to us, printed on the paper. Here we do not. So we have to go to our brains and say, what does kilo mean? Kilo means 10 to the third or 1,000. Kilo means 10 to the third. Now, if you want to write 1,000, that's fine, but I'm going to be consistent and use 10 to the whatever. So then over here, we look at this conversion factor. And we see we've got kilo on the bottom. Kilo times a gram. And we need the top to equal the bottom. We do not want to put what kilo means next to kilo. We want to put what kilo means on the top. So we're going to put 10 to the third on the top. Because let's play with this over here. So grams over kilograms. A gram over a gram is the same over the same, right? Those would cancel out. 10 to the third and kilo mean the same thing, and so those would cancel out. And what is this thing equal to? It's equal to 1. In all of our unit conversions, that fraction that we're multiplying by has to be equal to 1. Now, we're not going to cancel it out like that because we want to have the units be changed. But that's why we put the kilo and the 10 to the third on opposite sides. Because otherwise they aren't equal. So I'm going to get rid of that. I got rid of a little too much, didn't I? So now we have to do this on our calculator. And, we look at the 10 to the 3, and that's a little confusing. So we think of it as 1 times 10 to the third. I should have made this whole thing bigger. Maybe I'll get it right next time. 1 times 10 to the 3, that's scientific notation. Okay, that's easy to do on the calculator, or should be by now. That's the EE or the EXP button. So we're going to take 2.94 times 1 EE3 equals, and we're going to get 2940, and the unit will be grams. So now we need to think about our significant figures, and our starting number had 3 sig figs. This is an exact conversion, so we don't have to think about it. Our answer should have 3 significant figures. This answer as written is marginally okay. This 0 is ambivalent, not ambivalent, ambiguous. Maybe we're ambivalent about it, but it can't be ambivalent. It's ambiguous. The best way to write that answer is in scientific notation so that we can get rid of that ambiguous 0. And always, always include the units. Any questions?